Good morning. This is Diane Ducharme, and this is the fourth of four webinars introducing the NC Market Ready Fresh Produce Safety Field to Family webinar series. Our first screen is showing you how to use Illuminate. None of the participants have been given a mic other than the moderators that will be talking. However, on the left-hand side, you have a box that you can write in and send questions as we do the presentations. And I'm typing in, excuse me, I'm typing in a hello to everybody. Make sure that when you're sending it, it is sent to all of this room. So it goes to everybody if you would like. We will have time to take questions at the end. So if you feel like you need to type it in when they're talking, that's great. Go ahead and we'll capture it at the end. So today we'll be going through Module 6, which is water quality. This traditionally has been a big module for questions. It is one of the big areas that crosses both production and packing, harvesting time periods. So we'll be going through that. We'll end with some, again, taking your questions. And as you exit, there will be an evaluation and certificate. And we'll talk more about that as we finish the module. So Dr. Chris Gunter from Department of Horticultural Sciences will be taking us through Module 6. Chris comes with a background of vegetable production and is well versed with this and is doing some research on the water quality. So Chris, I'm going to pass the baton to you.
Okay, thanks Diane. I appreciate that. This module on water quality was developed by Dr. Keith Baldwin at NC University and Dr. Gary Graybo here at NC State in the Department of Biological and Agricultural Engineering. And so although I'm presenting the module, those were the folks that actually did the development. Today's learning objectives, just like all the other modules, we'll start with our objectives, and our goal is to familiarize you with potential sources of contamination of water used for irrigation and processing, and then best management practices for preventing contamination and protecting water quality on the farm. In addition, we'd like you to become familiar and conversant with water quality guidelines, both microbial, chemical, and physical characteristics for irrigation and for processing of fruits and vegetables. We'd like you to know the proper practices for monitoring water quality and disinfection of water used for irrigation, and then the proper use of water practices for processing in the packing house. The topics we'll cover will be gaps, considerations around water, focusing on water use on the farm, irrigation management practices, and water quality both pre- and post-harvest. Of course, the background you guys have already had, but good agricultural practices are the basic environmental and operational conditions and growing and harvesting crops necessary to produce safe and wholesome fruits and vegetables. The main mechanism for contamination of fresh produce is determined by the water quality that comes in contact with that fresh produce. Water quality can carry a number of different microorganisms that could affect and contaminate fresh produce. When we're talking about water, the key overarching theme is to identify what potential sources of contamination exist for the water that you're using, and a recognition that water that reaches fresh produce in a variety of means on the farm can affect that water quality. The pathogens in water we covered in Module 1 in great detail, but just as a refresher, E. coli and Salmonella are the two that we're most concerned about. However, they aren't the only pathogens that can be in the water that might affect fresh produce safety. Some others are listed here. The most common source of contamination for water is human and animal feces. We're going to cover a few best management practices for water, and these will become part of your farm's food safety plan. The first is to prepare a water system description. This is a basic, comprehensive description of where the water you're using on the farm comes from. Do a sanitary survey of that water system prior to the use of water for agricultural operations. Use irrigation water and water in harvest operations that is of appropriate microbial quality for its intended use. And there we're talking about two separate operations for water use on the farm. The first is irrigation water in the field, and the second is post-harvest operations, washing, etc., that happen in the packing house. So we'll talk about those two areas separately. Test water as close to the point of use as possible. So this refers to when you're taking a water test, for example, in the field, you want to test that water at the outlet of the field operation. So if that's the sprinkler, an overhead sprinkler, for example, you want to test it at the sprinkler, not at the point of uptake for the water. And then, just like all other GAPS practices, retain the documentation of those test results for your food safety plan. I've mentioned this already, but irrigation is not the only use of water on the farm. We also are talking about water that's used for agricultural chemical applications like fertilizer spraying, nutrient spraying, foliar, or pesticide management sprays, weeds, insects, and disease. We're also talking about water that's used for frost protection, or as I mentioned in the packing house, for post-harvest handling operations. Let's start with irrigation. So we've already spoken a little bit in the second module about the risks associated with drip and overhead irrigation. And I think it's clear that overhead irrigation has a direct impact on the edible portion of the produce. If this is a above ground plant part that you're harvesting for sale, and the water is spraying directly on that produce, it's clear to see there may be an impact of the water quality on that product. Drip irrigation or subsurface irrigation may be a better option if you're concerned about water quality coming in contact with the fresh produce. In some crops, frost protection is used, and the water quality at that time is also important. It should be noted here that with frost protection in a crop like strawberries, there may or may not be fruit on the plant at the time of frost protection. So that's another consideration, that the time of harvest for a crop like that becomes important when considering water applications or water quality when it's being applied. I'm much less concerned about water quality when there's no fruit in production. I'm more concerned when there's fruit being harvested and the water is impacting the quality of that fruit directly. For pesticide applications, crops can become contaminated with a microbial contaminant during those operations as well. We received a good question during earlier training on application of pesticides and microbial water quality. Grower asked, if I'm putting in a pesticide, an insecticide into my mix tank, wouldn't it kill the E. coli as well? And the answer was no, because the insecticide is designed to target insects, not the microbial contaminants in the water. So it's ineffective at killing E. coli, for example, but maybe very effective at killing aphids or other insect pests. So this is just a picture for the old-timers to show Gary Graybo's love of North by Northwest. The pesticide application can have a direct impact on plant quality. Manure storage is also an issue when we're talking about water. Raw manure shouldn't be placed in an area where it could run off from the storage area into and contaminate surface water sources or groundwater sources. Runoff from fields containing livestock can also be a problem. They can contaminate surface water with pathogens as well as increase nutrient load. And the picture you see here is of an algal bloom. That could be a symptom of a potential problem if you've got runoff from an upland area containing animals into this surface water body. This algal bloom may be a symptom of nutrient runoff, but also maybe a warning sign to check that water for its microbial quality. The recommendation is to keep grazing animals 30 feet from a water source, and you can see these cows are fenced off with an electric fence. When you're doing your water source survey, you may want to check those water sources for signs of animal intrusion, and you can see footprints near the water's edge in the other picture here. Livestock concerns exclude animals from surface water sources as well as from drainage to those sources. Using fences, buffers, buffer strips, or diversion areas, diversion berms, ditches to keep that runoff away from the production area or away from the water source. Buffer areas haven't really been defined in a legislative sense, so we don't have hard and fast rules or laws concerning that for water sources and fresh produce. So the basis of the recommendations you see here comes from the California Leafy Greens, and this is sort of a guidance document, not a regulatory document. The numbers you see here refer to the border between fields and water sources. For example, a 100-foot area between surface applied manure and surface water, a 30-foot leach field from the crop edge, or a 400-foot border from compost operations to the crop edge. Border width may be increased or decreased depending on the risk or mitigating factors. For example, topography. If the compost area, production area, is in a lower spot than the produce growing area, that may be enough of a physical area to allow you to decrease the physical distance. Other physical barriers that we haven't mentioned yet: berms, diversion ditches, vegetated strips, things like that, which might mitigate the runoff from those potential contamination sources into the water source. Usually in North Carolina, our agricultural water comes from one of these three sources: either a surface source such as a pond, river, or stream, or a well, either open or capped, or a municipal water system. In terms of surface water sources, we're talking about any surface water source that's used for agricultural use, like ponds, rivers, or streams. Well water from groundwater sources. When you're talking about well water, one of the things that we've had potential sources of contamination identified from are looking at things like the casing. You should check the casing of the well, check the integrity of the well. The outside of the well casing needs to be grouted. The casing should be surrounded by a concrete pad. This concrete pad really should be sloped in such a way that water that's poured onto the pad doesn't divert down into the well. It should be sloped in such a way that it diverts water away from the wellhead. Of course, good practices for well head protection also apply in terms of contamination for fresh produce safety. Don't mix pesticides or agricultural chemicals close to the well. Don't apply untreated manure near the well. Inspect the well annually. Use backflow prevention to prevent contamination from returning down into the well, and then retire unused or abandoned wells. In terms of water from municipal sources, we have those growers using those municipal water sources as well, and when that source is used, it's usually tested at the production area, the water company. So we're also recommending testing at the point of use, which would be at the field. Here's an example of sprinkler irrigation, and when we talk about water testing, we're usually talking about at point of use, which would be right out of the sprinkler head. And for drip irrigation, when we talk about water testing, we usually talk about right out of the end of the drip line. You should create a checklist for your irrigation system, evaluate any irrigation water storage conditions, and try to evaluate the means for reducing or controlling potential contamination from those water sources. This is especially important when we're talking about surface water sources, which you may not have control of the entire water system as it comes to you. So it's important to recognize in your checklist those events which may impact your water quality. For example, stormwater runoff upstream from your irrigation outtake. Evaluate irrigation methods for their potential to introduce or support the growth of human pathogens. So if you know that after a rainfall event you have significant runoff upstream from a neighbor with cattle, then that would be an inappropriate time to continue using that source for irrigation. Use procedures for storing irrigation, for example, pipes and drip tape, that reduce the potential for pest infestation. Drip tape in a subsurface irrigation with a water source that you don't have complete control of may be a better option than overhead irrigation, for example. Spraying and mixing pesticides for frost protection, use water quality that's equal to the water used for direct or indirect application to edible parts of lettuce and other leafy greens. And we'll talk more about the specifics of those in just a minute. When you're combining water sources, for example, sometimes you're using well water, but at times of high demand you also use surface water. Consider the potential for those sources to harbor pathogens and test those water sources appropriately. In this case, we recommend testing for generic E. coli. When you have a situation where the quality of the water that you're using is not in direct control by you, there are options available for reducing the microbial load of that water. Here's just an example. This is a simple chlorination unit that's being used by producers in a single pass irrigation system. The chlorination unit takes in water that's coming directly from the irrigation source, treats it with chlorine, and then delivers that water back out to the field with a significantly reduced microbial load. And this is an area that we're actively researching. I show you this unit here, this chlorination unit, but there are other options available besides using a chlorine type system, but I just put it in as an example for you. You should recognize also that water can easily become contaminated with human or animal feces. So just like in all of the other good agricultural practices modules we've discussed so far, you want to make sure that you provide workers adequately with adequate numbers of field restrooms, and provide those restrooms in a location that's close to the field. Encourage workers to use them. Also encourage workers to wash their hands prior to picking. All of these things apply to water quality just as they do to direct contact by the workers with the produce. Here we're going to start talking about water testing. And again, when we're talking about municipal water supplies, these are usually regulated water supplies that are required to be potable. Private well water may or may not be potable, and growers have the responsibility to test this water. And surface irrigation or surface water is subject to various uncontrollable influences, and that should be considered, that should make it considered non-potable water. Microbial testing is used to track the safety of the water, not really for daily monitoring activities. Records become a very important part of an outbreak investigation, and so they should be maintained as part of your food safety plan. Document the frequency and results of each water test for comparison purposes. What this really allows you to do is, over time, you can track changes in the water quality. So this helps you to identify potential sources of contamination. We're recommending that irrigation water be sampled within 60 days from the beginning of the season, and then additional samples collected at intervals of not less than 18 hours. So if you have to sample a water source multiple times, you should wait at least 18 hours before taking a second sample. During the season, we're recommending that surface water irrigation sampling occurs every 30 days. And if samples exceed the recommended limits, that you stop irrigating with those water sources and start looking for the source of contamination and remediate before that water is used again. When we're talking about what to test for, we have different options for testing. You could test for total coliforms, fecal coliforms, or generic E. coli. And when you're looking at this list, this list runs from least specific to more specific, less specific to more specific. So total coliforms, a subsample of those total coliforms will be fecal coliforms, and a subset of those fecal coliforms will be generic E. coli. When we recommend water testing, we're looking for generic E. coli. I'm trying to draw a little arrow here. Generic E. coli is what we recommend testing for water testing, and we recommend that producers ask the lab to give them not just presence or, not just presence or absence, but that they test for, that they give them a quantified test. So this will give them a number of generic E. coli per unit volume rather than just generic E. coli present or absent. These water quality guidelines that you see listed here come from that California Leafy Greens marketing agreement. Unfortunately, there aren't specific guidelines in existence for irrigation water quality. There's no regulatory guideline available for that, for irrigation water. So in the absence of regulation, we have to look for industry guidance, and this California Leafy Greens marketing agreement is currently one of the industry guidance documents. Now the next question I know that you all have immediately is, well, where did they get these numbers? So since there aren't hard science numbers in the industry to support irrigation water quality, we have to look for guidelines from other industries. And in this case, what they did was they got together a consensus of experts in water quality and looked for guidelines that exist already. And for irrigation water, there are good science-based guidelines for recreational waters. This refers to surface waters like lakes and streams that are used for swimming. We have good science to support the amount of microbial contamination in surface waters that may make you ill if you swim in those waters. So those, in the absence of any other science-based numbers, those numbers have been used to generate these recommendations that you see here. So in terms of generic E. coli, we're looking at less than or equal to 126 mpn per 100 mils. And you'll notice it says geometric mean of 5 samples. So this isn't just one single test result. This should be part of your ongoing testing process. So once you generate five water test samples, the mean of those samples becomes the number that you're interested in. Shooting for less than 126 mpn per 100 mils. The geometric mean just refers to, as new samples are taken, older samples are dropped out of the mean. So you want to take the mean of the newest 5 samples that you have. And then any single sample needs to be less than 576 mpn. So the mean is 126, but there is some guidance or some acceptance if you have a single event that pushes your sample up higher. There's a way to accept those you know, single events that give you a high water sample. Where the edible portion of the crop is in contact with the irrigation water, for example, an overhead irrigation onto leafy greens, the acceptance criteria is less than 126 MPNs for this rolling geometric mean, and any single event should be less than 235 MPN. Any single sample should be less than 235. Discontinue the use of foliar or direct contact water with the edible portion of the plant if the water sample is out of compliance or out of these guidelines. You should conduct a sanitary survey of your water source and distribution source to eliminate and identify any contamination source that's impacting the water quality. For wells, you should perform a sanitary survey and treat the well if necessary. Retest the water as close to the source as possible and at the same sampling point after conducting the sanitary survey and taking remedial action. Then you want to test daily for 5 days, about 24 hours apart, at the point closest to use. If any of those 5 samples is greater than that 235, you have not found the source of contamination, and you need to repeat that sanitary survey and remedial action. So basically what we're recommending is testing, looking for a problem, remediating the problem, and then retesting until you have found that the water source has come back into compliance. A more aggressive sampling program, for example, once a week instead of once a month, should be instituted if an explanation for the contamination is not readily apparent. So if you have water source contamination that keeps showing up and you can't find the reason for that, then you need to institute a little more aggressive sampling program because you don't have good control over where the contamination is coming from. And don't use water from the water system that directly contacts the edible portion of the crop if your water can't meet those acceptance criteria. For wells and municipal water sources, if generic E. coli is below detection for 5 consecutive samples, then sampling frequency can be reduced to once every 6 months, and the requirement for 60 and 30-day sampling can be waived. So this is a recognition that municipal water sources and well water sources are less frequently contaminated, and so sampling could be done less frequently for those sources. And again, these guidelines are not hard and fast rules. They're coming directly from that guidance document, which is the best guidance document that we have at this time. When you collect water samples, this is usually done based on a kit that you receive from the laboratory that is going to process your water sample. That kit usually contains a sterile sample bottle. It also usually contains some sort of sterile gloves that you wear while collecting it. The idea there is not to contaminate the sample that you're taking with any pathogen that may be on your own hands during the sample collection process. When you're collecting water from the distribution system, you want to allow that distribution system to run for a few minutes before taking the sample. That way you're not getting sample of what's residual in the pipe. You're actually getting a sample of what's coming from the water source through the distribution. Don't rinse that sample bottle prior to taking the sample. Of course, it's a sterile bottle, so it should remain sterile until the sample is placed in it. And try not to introduce any residual chlorine from that, for example, from rinsing the bottle into there, which may contaminate or kill the bacteria in the sample you're taking. When collecting pond water samples, you want to subsample from several locations around the pond. Do it about 1 to 2 feet below the surface of the pond. Invert the sample container until the desired sampling depth is reached, and then open the sample. Don't collect any of the floating debris on the surface, and try not to scrape the sides or bottom of the pond while you're sampling. Take samples at least 6 feet from the side of the pond. The idea there is to collect a representative sample of the actual water that's being used in irrigation. Use a collection container on the end of a pole, or by wading into the stream, or dipping the sterilized sample container into the stream. Remove the cap once it's below the surface. Plunge the sample container quickly below the surface to prevent collection of the surface residues. Leave 1 to 2 inches of headspace in the bottle to allow for mixing of the sample. And then once the sample is collected, it needs to be delivered to the laboratory as soon as possible, not more than 24 hours after collection. Samples should be kept on ice during transport, and check with the specific lab for any additional protocols that they may have. Each lab's operation may be a little bit different. Another area of concern in water quality is flooded fields. The FDA considers any crop that's come into contact with floodwater to be adulterated, and that commodity can no longer be sold for human consumption. The best practices for flooded fields are not to harvest within 30 feet of flooding. This prevents cross-contamination while you're picking. Plan for a 60-day time interval before replanting, providing the soil sufficient time to dry out after the flood event. You can shorten that waiting period to 30 days if the soil testing indicates the concentration of pathogens is lower than recommended standards for processed compost. So in that case, using the compost testing standards. Now we're going to switch gears just a little bit. We're moving out of the field and into the packing facility. Now, for packing facilities, water quality is different than that which can be used in the field. This is the post-harvest water quality section. Best practices here for washing produce include checking the available chlorine level often, or using a monitoring system that's automated. Use chlorine or some other labeled disinfectant in the wash water. Change the water at least daily. This could be more frequently if the commodity is particularly dirty and requires more frequent changing of the wash water. And monitoring those results is not good if you don't write those monitored results down. So once you monitor, you always need to keep a record of that monitoring. You want to make sure that the dump tank water is less than 10 degrees cooler than the produce, and wash and rinse and sanitize any belts or conveyor systems that are used regularly. It's important to recognize that a single error during this critical control point is capable of magnifying problems in sanitary or hygiene management. So one contaminated tomato here can then impact the quality of the rest of the produce that it comes into contact with. In terms of wash water, in the packing house, wash water must be potable, and it needs to be properly chlorinated to keep it safe. Testing procedures must be implemented to ensure that proper chlorine levels are consistently maintained. And then those maintenance records need to be recorded and become a part of your food safety plan. There are a number of agents used commercially to sanitize fruits and vegetables. Frequently we talk about chlorine, and that's just one of the sanitizing agents that's available. Others include hydrogen peroxide, periacetic acid, ozone. A number are listed here. Water that comes into direct contact with produce should meet the EPA guidelines for microbial drinking water standards. And we're lucky to have Diane supporting us today. She has given you the link at the end of this document for those water quality standards. That generic E. coli test that we talked about earlier needs to be negative or below detectable limits in order for the water to be used in the packing house. If it is not, then a remediation step needs to be applied. Greater than, when testing for free chlorine in remediated water, you need to be at greater than 1 ppm of free chlorine. The pH should be between 6.5 and 7.5, or if you're using the ORP method, it's greater than 650 millivolts. Other approved water treatments for human pathogen removal, as long as they're EPA labeled, may be used. I'll talk about chlorine a little bit because that's the most commonly used sanitizer. You want to maintain those levels of chlorine between 100 and 150 parts per million, depending on the produce that's being washed. The pH needs to be between 6.5 and 7.5. Drain those dump tanks at least daily and refill them with clean, potable water prior to use. And then use things that help to reduce the amount of organic matter and debris in the wash water. That will help maintain the effectiveness of the chlorine for longer periods of time. Self-cleaning screens, for example. Here's a chart that shows the different recommended chlorination strengths for washing different produce items, and also the process that's commonly used for those produce items. So for example, in bell peppers, we're shooting for between 150 and 200 ppm chlorine, free chlorine on the sprayer belt. In the dump tank, it would be 300 to 400 ppm. For melons, it's 100 to 150 in both the dump tank and the sprayer. Monitor that dump tank water. Dump tanks, soaking tanks, washing lines. Each of these steps where water comes into contact with the fresh produce, that's where the monitoring should occur. Anytime water is used in the packing facility, you also want to maintain that water quality in those areas as well. For example, hydrocoolers, water can infiltrate the commodity during that process, and that needs to be monitored and maintained with potable water. Ice is another area. Ice should be made with potable water, and the quality of that ice directly impacts the quality of the produce. Here's just a sample record sheet for a producer to use on their packing line. It gives a place for the date, the time of sampling, the amount of free chlorine at that time, the pH of the water, and a place for the person who took the test to put their initials. It's a simple form. It doesn't have to be a complicated form, but this document shows that this chlorination monitoring happened at specific times and that it was maintained at a specific level. Monitoring can be done in a number of ways. There are simple test strips, for example, that show available or free chlorine. There's colorimetric kits, like you may be familiar with for swimming pools, for example. The sample dilution may be required for those, and that sample dilution should occur with distilled water. And there are also electronic sensors that can be used. The oxidation reduction potential that we mentioned earlier, ORP. pH can be checked electronically or with a test strip. I've given you a few resources here. Some of the commodity-specific food safety guidelines for leafy greens. And then also the guide, as we call it, for minimizing microbial hazards is here. The GAPS, National GAPS program at Cornell. Davis has a good self-audit for growers and handlers. And then the audit verification system from the USDA, which you should all have in your packets as well. All right, that's the last slide that I have. So are we going to do questions at the end of this section, Diane, or at the end of the entire program?
I think questions now, and I've been gathering those. So one of the questions was, what is the approximate cost of the chlorination unit that you showed? Yes.
That's a good question. The cost of the unit varies, of course, based on the capacity that you need. The one that I showed in the picture has an included pump, which bumps the price of it up. That unit is $2,000, but almost $1,000 of that unit is the chlorination, is the pump itself. Which the reason we had the pump, or had to have a pump, is to go back in on the high pressure side of the system. Other installations that don't need that high pressure pump could be done for about $1,000.
And in fact, right now there's a couple of grants. This area of water quality is, again, the hot topics, research areas, and is now funding last year and this year a research that's going on for low-cost options to provide chlorinated water to areas. So hopefully we'll be seeing some good options, low-cost options. Okay, next question is, do all the sampling agencies use the same measures, NPM, most probable number per 100 milliliters? That would be really great if they all did. As you well know, nothing ever is consistent, and I'll pass the baton to Chris on that one.
Yeah, unfortunately, Diane's correct. The water quality guidelines are not the same for every lab. That's why we're recommending that growers specifically ask for a water quality test that gives them a quantifiable result so that they have an actual number. Some labs will test just for presence and absence of E. coli or coliforms, and it's very important that producers recognize that the number that they want is a generic E. coli, and they want that number to be a quantified number.
Now that said, what some of the growers are coming up with is some of them are showing that NPN, most probable number, and some of them are having CFU, which is colony forming unit. Colony forming unit and NPN are numerically equivalent to one another. So those can be used interchangeably. Okay, next question, and I've got the slide up. Yes, that is true. So the next question is, why wasn't there a recommendation for chlorination in the tomato wash water? And I think that was probably just left off that slide maybe, but I think generally it's 100 to 150, but again, I'll pass it to Chris.
I like how she passes me these, which I'm not sure of the answer. I think it's just a typo. There should be a number there, but I'll have to check with Gary and Keith to find out what it is. 150 sounds correct to me.
I'm pretty sure yeah, it's 100 to 150 because we've talked about that before. So that is your answer, 1 to 150. And that would be on the dump tank and the sprayers. With tomatoes, it's they have found some, as far as what Chris was talking about, that 10 degrees differential, because it moves down the osmotic potential and can actually, pathogens can actually be moved across the skin and into the tomato pulp itself. So that's another area of concern for the tomatoes. Next question. Was there any information on how to remediate water in the field provided? Would it be good to provide growers with some guidance on what to do when water in the field is out of parameters? LGMA has good resources. Chris, do you have comments on that?
There are options available for producers if that water needs to be remediated. The one that I showed here was that chlorination unit, but there are other options available. The first thing that I want to emphasize is to find out where that source of contamination is coming from. That's the most critical piece. Once you identify where your contamination is coming from, then you can take the appropriate steps to remediate the water. But until you know what's causing the contamination, it's very difficult to apply control measures.
I'm sorry, I was still looking for that, the remediation. We actually had quite a bit in this notebook on remediation, and particularly taking it from that Leafy Greens marketing agreement. So we'll pull that from our notebooks and send that out so that you've got the answers to that. And I agree, Antonio, that would be helpful for them. Are there any further questions right now? Okay, I think we've captured everybody. All right, so I'd like to ask you some questions, as I've done a couple times now. We're going to use our poller here. So when we go, if you click on your name, and you can use the green check would be yes, and the red X mark would be no. So I'm going to put a little check mark next to me so you know. All right, the question is, the most common source of water contamination is human or animal feces. True would be green check. Okay, looks like we've got some good, thank you. That's great, guys. All right, what about water is not considered a source of or vehicle for microbial pathogens? Excellent. All right, that should be false. Okay, so the next one, it's important to use potable water to mix pesticides so that crops don't become contaminated with pathogens. Right, your answer is true. All right, one more. A quantitative total coliform water test is the best microbial test available, indicating the safety of water for production or post-harvest handling practices for produce. Again, a quantitative total coliform water test is the best microbial test available, indicating the safety of water for production or post-harvest handling practices for produce. All right, we're getting a little bit of a divide on this one. All right, the key here is that what I said was a quantitative total coliform water test is the best microbial test. Indeed, we want a quantitative test, but total coliform is not the best test. Total coliform, if we go back to all the tests that are available, total coliform is the kind of the baseline test. It would give us kind of all of the spectrum of bacteria that's out there. Fecal coliform would be your next test that would be a little bit more specific. And then your generic E. coli is going to be the most specific, and it's targeting really what we want to be seeing in our water quality and the pathogens of concern. So really on this one, it would be false, and the best test, microbial test, would be a quantitative generic E. coli test. Nice, excellent. I'm glad we were able to do that. Okay, so it is 10 o'clock. I wasn't sure how long this session was going to be. We put generally 2 hours to make sure that we encompassed all of the questions and make sure that we had time for anything else. Do you all have, now that you've gone through the 6 modules and essentially Tier 1, do any of you all have any further questions that we might be able to address? Because this will be the last of the webinars, and I'll have you go through an exit evaluation here in just a minute. Okay, there's a couple of people writing, so we're going to give you just a minute. Just so you know, if you have sent me side emails with questions, I will answer those, and hopefully we'll be able to put these questions, the Q&As back and forth that I will answer. And yes, Jan, I did get your emails. I just haven't had time to answer them. I'll do that this afternoon. Wick, do you have a question? There we go. All right, water testing. If we had an incident, I'm assuming this is an outbreak incident, testing doesn't matter. Farmers will probably test to a positive and stop. I'm not sure what, that's not really a question. That's discussion. Okay, so, all right, water testing. So, a new thing that's come on the books for the processed industry is and it's not just water testing, it's tied into microbial testing. If processors are testing, they have microbial tests that come back positive, they need to, and Chris, help me out here because I can't remember. They need to report it back to whether it's FDA or FSIS, depending on who the regulatory agency is. They would have to report that back. Now that said, that's specifically as of September 1st for the processing industry. However, knowing that there's regulation in the Senate right now, there's a House bill that passed this summer. The Senate bill is in committee. Committee has passed some recommendations, and it will go to the full Senate and see how the Senate and the House bill will mesh there. They might be looking at some of those parameters there. So, Chris, do you have anything to add?
I'd just like to clarify, Wick, when you're talking about if we have an incident, water testing doesn't matter for small or large growers. Can you just give me a little more information about what you mean about testing positive and stopping? Do you mean if they have a positive water sample test, they'll stop irrigating? Or I guess I don't understand the question. Oh, of course. Okay. And yeah, if that refers to the fact that during an outbreak, if you have a positive or negative test, but an outbreak is happening and the farm is implicated, the water test, I guess, in that sense, it just becomes a documentation of what you have found. So if you had negative water tests or positive water tests, it's not gonna save you from an outbreak situation. The contamination from water is only one of the potential sources of contamination. There are other sources, so it could be all the best management practices for water in place, and yet contamination still happens from a human, hands, a sick worker, for example, or it happens out of the farm itself, happens off the farm. Someone else causes the contamination.
And I think, you make a good point that Antonio is actually piping in here. That's happened to us, and
Okay,
believe me, you better have records of water testing. That's what I was going to say. You need to, there's kind of a twofold avenue here, and one is setting up practices. And then the test or allowing you, the microbial test, or letting you have verification that your practices are indeed working. And it's that due diligent documentation. If it's not documented, you're not doing it. So you could say we're doing all these practices, but unless you have that backup of the test showing that indeed you're doing these practices, and this test is showing that at this point in time it's effective. It's very important. Let me go to John Kimber's question as far as, would you propose the webinar format or a live format for group training of growers? Ideally, the reason that we did train the trainer is so that there is the time to have this face-to-face interaction, so that there is the ability to have the verbal discussions. With the webinar, you're somewhat limited in that we've not given you all mics. You can only type in your questions. And that somewhat limits that interaction, not only between growers, but between the presenters and the growers. So ideally, I would recommend face-to-face training for growers and using the infrastructure that has been set up on this Train the Trainer program for the curriculum. That's the ideal situation. And the reason that we invited a select group of growers on this is because you've either been involved with the North Carolina Fresh Produce Safety Task Force, or you've been significant in questioning and delivering some information to, or being a liaison to growers that need this information. So that's kind of what our thinking on. let's see, Antonio, do you have anything else that you picked up on during this presentation or during the whole session that might be helpful for us pointing out as we move forward in our trainings? No, great. Thank you, Antonio. And I see Jan McGuinn is a question, hopefully. Okay. During the previous trainings, have you given growers copies of the resource material? We've left that up to the agents, and what I've typically seen, Jan, is the agents giving growers a copy of the PowerPoints. So you've got PowerPoints, and then you should have a whole resource notebook that gives you all of the slide notes plus additional resources. It gives you the pre and post test. It gives you all of that. So in each module there's handouts, like there's a case study that I went through on 5. It has answers, and it also gives you some suggestions on different things you can pull off the web. So as a whole notebook, I would not give the whole resources, because hopefully you're delivering that verbally. So that's typically what I've seen. And the idea here is to be able to take growers through this as they step through it on their own farm. Each farm is different, and so it needs to be tweaked. And Ben actually mentioned something yesterday that I meant to follow back up on, and I forgot, is I mentioned yesterday having a sample food safety plan. And what Ben's point was is, yeah, this is a great way to start. It gives you some framework, but it needs to be tweaked by each of the growers and their growing conditions, because each one is different. And when the growers start making their food safety plans and they start documenting things, they need to make sure that what is being said is what they're doing. It doesn't make sense to have something said out there saying, yeah, we're doing this, and not be able to document that you're doing it. Because again, it all comes down to, unless it's documented, you're not doing it. Okay, one of the questions here is David sent out, have you noticed any discussion about support for small producers or special considerations for small growers related to the cost and technical requirements to implement these requirements? So yes, indeed. And Chris, I will pass it on this one, because you were part of the North Carolina Fresh Produce Safety Task Force. In the last management meeting, talked specifically about this, about starting another kind of small growers group. But there's also been discussions with FDA. FDA came here in, was it August or September? I can't remember now, to talk specifically with small farmers to see what, how this all works within their systems. I guess I always go back to, it's got to make sense. If it doesn't make sense, both business-wise and economic-wise, then they're going down a road that they don't need to be going down. So Chris, I'm going to pass that baton for you.
Yeah, I think David, you've hit upon a real hot button issue for the area of fresh produce safety. Small farmers are very concerned about the financial burden that fresh produce safety may place on their operations. And just as Diane mentioned, the Fresh Produce Safety Task Force is really gathering information from growers of all sizes in the development of these educational materials, and also in the development of our goals and objectives for our group. There's a very, very strong recognition that gaps practices and food safety needs to be based on the size of the operation, the end market that the produce is going to. Those considerations have been taken into account for all of the activities that we've done so far. On the task force itself are growers of all sizes. So it was those growers, the input from those growers, that really helped us shape this tiered approach that we talked about all the way back in the first online training that we did here with you guys. So that's really been a consideration all along. Those size-specific considerations were also part of the talking points that the group has developed, and those growers who went to Washington, D.C. to talk to legislators, that was one of the key points that they took up there with them. As far as the special guidance for small producers, this level of training that you've gone through now, that level of training, that first tier, is the guidance that we're using for large and small producers. There isn't a difference in training necessary for producers of different sizes for this basic level of understanding. What really comes into play will be if there's some kind of certification that needs to take place, or third-party auditing, those kind of things that we're concerned about.
Yeah, and I think the question, when will special guidance be available for small growers? We can say that here in North Carolina, this is the program that we've established based on all the information and input from small, medium, and large farms. And the educational approach that we're recommending is this. And as we said, that visual of the tiered program, so they start here, everybody, we feel, and that was actually coming from growers. That was the recommendation from our working group 3, that everybody, all growers, regardless of size, have at least this basic tier 1 education, and then would move up the pyramid as markets, and now we have to put in as legislation might be required. As far as I want to talk, so that's kind of in North Carolina and what we've recommended based on the focus groups and the working groups that we have in effect right now with the task force. Now going to what's happening in legislation, as far as will there be exemptions? I mean, we've certainly heard, will farmers small farms be exempt from some of these things? And we don't know that. That's something that we're encouraging growers to keep an eye on as this moves forward. We certainly have our working groups in place and have our infrastructure to kind of start commenting on different aspects that are coming out of the House and the Senate. But it's a little bit of a crystal ball right now. And as that moves forward, we will adjust as much as possible. And if you remember, there's Tier 1 and Tier 2 that are outlined. Tier 3 is not outlined yet. There's certainly ideas, and we know what we want there, but we're giving ourselves a little bit of wiggle room here because of impending legislation. Okay, I hope that's captured everybody's questions. Certainly, as we move through this and as you get more involved, get more growers asking you questions, and as you get the materials and look through it, please send emails. Keep those questions coming, and we'll keep sending you resources. And sometimes we're going to say we don't know. I will tell you that, but we will get you the best information that we can. The timeline for Tier 2 is 2010, 2011. So we're looking at probably next year during the conference window, and I put the timeline of like October through March time period in which we'll start rolling out that Tier 2. The next question is from John. Wants to, let's see if I'm assuming that's the North Carolina Fresh Produce Safety Task Force wants to begin planning sessions during
the Sweet Potato Commission, Diane.
Oh, thank you. Sorry, John. If they want to begin planning sessions in 2010, can you advise the likely when we could begin? John, that's a topic that we can have on the side and start talking about that, because we do have a sweet potato grant that will be addressing some of this, and that timeline's a little different. So certainly we can talk about that as we go down into that those grant deliverables. Okay, so the next thing that I'd like to take you through is when you exit today, you will be directed to a survey. And the survey is to, it's actually broken up into, I think it's 5 areas. The first area is participant information. This is important because I need to have this if you have attended, and as a grower or agent, I want to capture that you've been trained and also get you a certificate if you're a grower. Section 2 will be presentation evaluation. We want to know, was this important? How was the training? You know, what kind of feedback from you on that as far as did it work for you? And then the knowledge evaluations would be Section 3. Section 4 is just demographic information for us, and then Section 5 is just dealing with Illuminate evaluation. Was this an effective tool for you? Did you like it? How did it work? Was there any glitches? Anything that we can make better as we move down this road of the electronic resources. So if you do not get directed to the survey, if you could please contact me and I will send it to you, send you a link so that you can get that. My email I'm going to send across right now. Most of you should have this, but just, oops, it helps when I spell it right. Most of you should have it, but there it is. And we appreciate your attention. We are a little short today, but that was my intent, to be able to have and allow enough time for questions, Q&A, and we can go back and forth. So as far as how to exit, how you traditionally exit for if you are all on, I understand that between PCs and Macs, they're a little different way to exit. For the PCs, you go up to File on the left-hand corner, and you go and click on Exit, and that will bring up the survey. On the Mac, I think it's Exit Session, and I'm not sure how to get that, but hopefully those of you that have a Mac understand how to do that. Okay, at this time we're going to end the webinar. Please let me know if you do not get that survey. Thank you so much for your attention. We appreciate it. I hope it was helpful. And again, please continue with questions because it is an ongoing continuum. And Chris, do you have any final words?
Yeah, I just want to thank everyone for participating. I really appreciate your time, your questions, your input. Really fuels not only what we do with this training curriculum, but also with all of the efforts of the task force and even our research efforts, educational efforts. Those things are all really driven by your questions, both as producers and also as agents talking directly with producers. I encourage you to continue to do that. Your hard work and your input has really helped us to get where we are now, and I thank you sincerely for that.
Thank you all, and have a great day.